I no. Just a moment. Okay, I'm just going to unshare quickly. Why is this not working now? Sorry about this. That is not there. Okay. Can you see it again?
Yes, well, I can see your screen, but not Spider.
No, I can't see Spider. Okay, it's not duplicating it correctly. Sorry about this. Okay, there we go. Right, there we go. It should now be visible to everybody.
Yes.
Okay. Should I make that a bit bigger?
Yes, please. Yeah.
Okay. So I'm going to take a step back. I know that there are apparently quite a few people who are quite proficient in Python, but to try and explain some things, I'm going to go all the way back to some very, very basic Python to try and explain why Numpy is useful. So up until now, we've been looking at pandas, and pandas is a very, very useful tool for dealing with certain kinds of data. I would argue Numpy is useful to people who are dealing with slightly different computational problems, although there's some overlap. So you should think of Python as being a toolbox, and there's a lot more different tools in it than just a hammer. You know, they say when you've only got a hammer, every problem looks like a nail. So Python gives you a whole toolbox, and one of the tools is pandas, and one is Numpy, and you can certainly use them all together. They play nice, very nicely. But you can do a lot in just basic Python. So quickly going to, where is Slack? If we wanted to, just with basic Python, if we wanted to print out the squares of all the numbers from 1 to 10, does somebody want to volunteer a little snippet of code to do that? Pop it in Slack, and nobody bites, I'll do it myself. If somebody is typing, that's a positive sign. So I'm going to demonstrate a lot of things on interactive mode. That's when you type commands directly into the Python terminal. It's in the bottom left-hand or bottom right-hand corner of Spider. Okay. Neither of those are actually complete solutions. So let's have a look at this. Let's look at how we're going to do this in Python. The person who typed out 2, 4, 6, 8, 10. Okay, people are getting better. What I was looking for is something like this. What did we say? From 1 to 10. If you just want the numbers themselves. Okay, for loop. Okay, if you know any programming, you probably know about a for loop. All right. To some extent, what pandas and Numpy as well manage to do is to help you to get away from this kind of thing. So if you want to print out the squares of the numbers, how do we do it? Well, then you've got to do this, right? Oops, not that. So you've got to go and explicitly tell it to do a whole bunch of steps. Okay. For I in range, those who don't know the range function are completely new to Python. It goes by default. It will, if you just tell it to go up to range 10, it will go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So you give it a start point, you can give it an end point, and you can give it a step. Okay. Now there's some limitations of this. What happens if I want to go in steps of 0.5? What's going to happen? Well, if I push enter there, nothing. I'm used to doing this on the command line in Linux. Just, yeah, okay. No, not that. Bear with me. Right. You get an error. Traditional for loops in Python, you can use them with lists. So you can generate a list of things. We don't want to go too much depth into that, but the range function works with integers only. In the real world, is mostly floating point, unless you're dealing with people. You can't have half a person. I left my chainsaw at home. Yes. Oh, somebody asked me to put a white screen. Thank you. Where's the options again? Ooh. Where's preferences? Oh,
Yeah, it's view and
I use
preferences.
a different IDE normally. Got it? Okay.
Main on top. Just click on spider, the one above spider dock.
Oh,
Yeah.
there we go. Now I've lost. Yeah, when I'll get there, get there. All
And then
right.
you also have to do main interface theme as well.
Oh, okay. Hold on. Oh, let me go back. Sorry, I'm a bit slow today. Okay. Come on.
Then go by interface theme, light.
Light. All right.
And that's all.
Had to restart. Lots of fun. Okay. Is it coming back? Where does it go to now? Ah, it's making its epiphany. All right. Okay. Okay, it's finished thinking. It's old like me. All right. So, as I said, real world, we don't tend to work in terms of decimal, no decimal. We tend to work in terms of floating point numbers, 3 point something. Certain things are integers, most are not. The temperature is never exactly 24.0000 infinitely zeros degrees. It's 23.987 blah, 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 or something like that, right? So that's the first thing. Now, the second thing is that if you've got a list, you can put whatever you jolly well like in a list. Might have to put that the other way around. That's an imaginary number, by the way. Python handles imaginary numbers just out of the goodness of its heart. The default Python will handle imaginary numbers if you need them. 3. So I've got 4 different kinds of data types in there. I've got a character or a string at least. I have got a imaginary number. I've got a floating point number. And if I actually put a comma there, and Python will quite happily, it doesn't really care that they are all different types, which is handy for certain things, but let's be honest, most of the time, you want to actually have an array-like object, a matrix, whatever, it's all going to have the same type of elements in it, and most often they're going to be floating point numbers. So now we come to Numpy. Should I make this a bit bigger? It looks very small here. Better? Right. So Numpy has got a couple of useful things which extend basic Python. It does not extend it as far as pandas do, and it's not quite as everything is a great big giant text file with loads and loads and loads of metadata in it. It doesn't go quite to that extent, but it gives you a lot of tools for managing arrays of data. When I say an array of data, think basically of a table of numbers. They're mostly just numbers. It can handle mixed data to some extent as well, but mostly that's not what it's for. Then rather use pandas. And pandas can quite happily convert back to Numpy if you need to. So you can get the best of both worlds. So let's start off with this. In Numpy, there is a function called arange, which means array range. Now this works a lot like the range function in Python. You can give it a begin, an end, but you can give it a step. Sorry, I should use the alias. By the way, those of you who are not familiar with aliases and things, usually you want to, although it was amusing to see that you could put fairly long aliases in the thing, usually you want to use a shorter alias because that's the whole point of it, so you don't have to type so much. Okay, what does X contain? There we go. So whereas it caused an error when we tried to use range, and in fact, if we try to use the range function, see, it's still an error. Numpy will happily swallow it and return something which it tells us is an array. This is why I'm using interactive mode, by the way. So it interprets the lines one by one so you can see what each line does. And it's because then it will show you what it's doing. When you're writing anything more than about 5 lines of code, please do not use interactive mode. If you really like working in a slightly chaotic way like that, rather use Jupyter Notebook. It's not my cup of tea, but for many people it works really well. And that gives you a sort of a compromise where you can at least go back and change things if you need to. But for demonstration purposes, this is quite useful. So it tells us this is an array. And it gives round brackets on the outside. And then inside that is something which looks mightily like a list of floating point numbers. If you want to make it back into a list, you just say list X, and that's not part of NumPy. Python will take anything that look like it sort of should be a list, and it'll, in most cases, turn it happily into a list for you. And that's just a pure list. All right. So we've got this thing. That hasn't changed X, by the way. So X is still an array. What is an array? Array is basically a list-like thing of numbers. Now it's got various properties. We can say X dot shape. And it tells us that it's got 30 things in it. Okay, you can go count them if you want to. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, blah, 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 blah. Okay, so there's 30 of them. All right. Somebody's made a comment. I'm going too fast. Unfortunately, there's not a document. I'm standing in for someone for this in short notice. We will upload documents. Okay. But at the moment, the plan is just to give you a rough taste of the sort of things NumPy can handle. Okay. I'll try and go a little slower. But thanks for that comment. Okay. So in NumPy, I can basically make a container for numbers called an array. What happens if I go, let's say we've still got that list, A equals, or a list, I think we had, right? Let's make it A equals. Let's just make a list again to demonstrate a point, another difference between a NumPy array and a list, which is kind of important. So I've got a little list of numbers. In this case, they're integers, doesn't matter. If I say 5 times A, it just basically repeats that list 5 times and gives me a new list, which goes 1, 2, 5, 6, 1, 2, 5, 6, 5 times. All right. What happens if I take my array X multiplied by 3? Well, NumPy knows that it's dealing with numbers, so it goes and multiplies each element by 3. Okay. How would we have done that before? Suppose we wanted to multiply each element of A. You'd have to do something like this. For num in A, print. Well, you could have it make it even more complex. If you just wanted to display them onto the screen, you could do it like this. If you want to change them in A, it takes a bit more code. Okay, so you could do something like that. And if you wanted to store, if you wanted to overwrite them in the thing, it would be a bit more difficult. Now you could create a list, you could go and append them on each time, or blah, blah, blah. So the point is, by using NumPy arrays, if you're doing a lot of arithmetical operations on large sets of numbers, you save some typing. This is very useful for people who are doing moderately intensive mathematics on large data sets. Engineers, physicists, probably plenty of other people in other fields too, but those are the ones where I think it's really going to actually have a major impact. Please tell me if you feel that it's also true. Okay, some other people are also not keeping up. Okay. Okay, so people say I'm going a bit too fast. Okay. Okay. So, was everybody who is okay? I'm told that most of the people here are fairly familiar with Python. Do we need to? Was everybody okay with the for loop? Let's start off there. No. Okay. Okay. Some people are familiar, some are not. Okay. Okay. I'm just trying to guess whether the people who are responding more, or not guess, but give an educated count of whether. Okay. Notes, please. Yes, the notes will be made available. Unfortunately, I don't have any available at present. As I said, yeah, this was a short-term arrangement. Basically, I'm filling in for somebody, but we will make notes available when we can. If you look on I posted a link. If you want notes on basics of Python, the tutorial I mentioned in Slack on the Slack channel yesterday is a very good place to start. There are many others as well. Those will probably be more thorough than any notes I can give you, but that's okay. Also, in the meantime, have a look at numpy.org. That is the official documentation for NumPy. Okay. It looks like there are slightly more people who are struggling with the basics than who know it, but there's a significant number who know it as well. Okay. I see that guy did actually get the right answer. Okay. Okay. Person suggesting that I do everything as a script, so we can do that. I'm happy to do that. It is the better way of doing things. Okay. So, for the people with no background in programming, a for loop, well, we're going to use that. I'm just going to compare the two different ways of writing out the numbers from 1 to 10, and then writing out the squares of writing out the squares of those numbers. So if you're doing it using conventional Python, okay. So for those who don't know, a for loop is a way of getting the computer to do the same thing over and over and over again up until it's done it a certain number of times. So I could say for I in range 1 to 11. And it starts off with the number that you give it in the first slot, and it goes until it's one step less than the final number. So I have to go to 11 if I want to include 10. And you put a semicolon. What's it doing over there? And then I can just say print I. Yeah. And if I want, save that and run it. Okay. So that's just going back there. So it goes along I equals 1, it prints out I equals 2, prints out I equals 3, prints out I equals 4. It goes on until it gets to I equals 11, and then it's, okay, I can't go any further. Stop, don't print out I anymore. And then it does whatever else is in the program. Okay. We said that won't work if you are trying to use a step, which is not an integer. So now we can do the same thing for I in np.a range, 1, 11. But now we can do it in steps of 0.5 if we want to. Okay. Okay, so now it'll tell us what it's doing each time. Let's run it. Okay, so using just Python, I can get the numbers from 1 to 10. Using Numpy, I can do it in fractions. I don't have to use step size of integers. Right? Does that make sense so far? Okay, good, good, good. Luyanda, we're going to come to that in a moment. Okay. So we're basically doing the similar things. You can actually cheat and do this in Python as well. It's a lot more trouble. It involves a lot more writing code. If you try and cut a piece of wood with a hammer, you can do it. It's going to take you a very long time and it won't look very pretty. Your grandmother will almost certainly not like the table you make, or at least she might say it's nice, but not put it somewhere in a garage where visitors can't see it. She won't serve them tea on it. So, okay. So again, using the right tool for the right job. Okay. So by using the arange function, we can create an array which contains numbers and floating points. Okay. Now, let's square all of the numbers. Just using a list, let's square all of the numbers between 1 and 10 and put them into a list, or 1 and 5 to make things easy, right? Let's do it in conventional Python quickly. We say squares equals, we're making a list, we make an empty list, and then we're going to say for I in range, one to 6, right? We have to go 1 more than 5. Squares dot append I times 2. I can say I times I, or I can say I times 2. I times I is, of course, I is also I squared, right? And then after that, we can tell Python to just print squares. That's an ugly way of doing it. You normally want to format it nicer, but hey, this is just for demonstration purposes. Okay, and there you can see it's done it. 1, 4, 9, 16, 25, right? Just for the sake of keeping things nice and tidy, let's comment that part out now. All right. How are we going to do this? Okay, now let's do it using NumPy as well. Where's equals. All right, it has the same result. Which one would you rather use? Which one takes more typing? This one takes half as many lines as that one, isn't it? Why? Well, we don't have to mess around with for loops now. I think it's important to know how to do for loops, but because there are certain times you can't get away from them, and if you just know how to use the functions in NumPy and things, you can sometimes get stuck when there's actually an easy way of doing it. But a lot of the time, if you can do this, you're absolutely going to do this. It's just so much quicker, and mathematically, it's just nicer. It looks almost like the maths. Let's give another example. Let's do it a slightly different way. Oops. What's it trying to do to me now? Okay, so now I'm not throwing away my initial values. I'm keeping the numbers from 1 to 5. I'm putting in spaces there. It doesn't matter. Python doesn't care unless the only place Python cares about spaces is in front of the thing. Don't do that unless you're going into a for loop or something. Okay, but inside after the first character, it doesn't really care where the spaces are, or after the beginning of the actual command line, right? So you'll agree with me, I hope, that this is very similar to what we were doing before. But if we include matplotlib, because I'm an old fogey and I like old things sometimes, let's use matplotlib. So we can plot these, can't we? We've got an X and a Y, let's plot them. Okay, you want to make it green stars? Let's make it green star. No, make it red stars. So that we can actually, yeah, which will horrify, just to be controversial, you'll use red stars. The Soviets will love us, comrade. You can decide whether or whether my comments should be interpreted ironically or not, depending on your political leanings. I don't really care. And then remembering that we've got to say plt.show. Okay. So this is actually pretty powerful. You can create an array of values, and then you can treat that array as if it's basically just a single number, and it'll do it element by element. That's not all you can do, though. You'll agree with me, I hope, that X and Y have both got the same number of elements. If you don't, let's check. We can go here and we can check it, but I want to show you something else. So each array has got a property associated with called shape, and that tells you how many rows and columns it has. Now, by default, if you're using something like A range, it's one-dimensional. So it doesn't actually care whether it's a row or a column. It's got a certain number of elements, one after the other. Okay. When you get to two-dimensional arrays, things get more complicated. But let's first just look at this. I want to show you something else first. Okay. I'm going to print out X shape and Y shape. How many elements should there be in each one? Stefan, you're quite correct. You should always use n plus 1. If you are using Numpy, of course, you can be n plus your step size. It doesn't have to be 1, but 1 will probably. So you should just be a little careful then. The person who asked what I imported last, it was just matplotlib. All right. So let's run this again. Yeah, you see, it says look at X. X is the shape of X is 5 elements. Shape of Y is 5 elements. Okay. So if they're the same size, what's going to happen if we add them together? Let's do it before we. So anybody like to guess what's going to happen if we add X and Y together? Any of you guys want to guess? I'm asking my people now. Right, somebody online has it? No? No brave souls. Come on, what do you think is going to happen? What would happen in MATLAB if you added two arrays of the same size together? Yeah. Element by element. Okay. There we go. Somebody's done it. So if anybody's familiar with MATLAB, and I'm very sorry if you are, really, nobody deserves that kind of brain damage, but no, I don't like MATLAB much. Actually, its syntax is not that different from Python, but it's slow and you have to pay for it, and Python's better. So yeah. Okay. So let's see what happens if we run this thing now. If you did it in MATLAB, and that chap who suggested that that was the answer is quite correct. It adds it element by element. So the first element of X is 1. First element of Y is 1. First element of X is 2. Second element of Y is 4, the square of 2, and so on. So you can see how this works. Okay, really good. You can, in fact, actually use Python with Numpy like a drop-in replacement for MATLAB. Okay? And with minimal effort, if you're using Numpy and matplotlib together, and if you're using it through Spider, heck, it even looks a bit like MATLAB. Right? So for any sort of basic computing where you're dealing with long strings of data, you can use Python, Numpy, and matplotlib. All right. And you can add the things together. There's a difference if you multiply the two together. So let's make it X times Y. In the case of MATLAB, oopsie, not X8Y. In the case of MATLAB, for those who actually have been subjected to that horror, what would happen there? It's going to try and do a matrix operation there, right? In Python, it doesn't do that. It will multiply the first element by the first element of Y. The second element of X by the second. It's like the dot operator, if you know MATLAB. Okay, let's just show you what it does, because some characters on the screen paint 1,000 words. Okay. Tell you what, let's just go X, Y. Okay, 1 times 1 is surely 1. 2 times 4 is 8. 3 times 9 is 27. So it's basically the cubes, right? Okay. Now, what happens if you actually want to take the dot product? You actually want to do, or you want to do matrix multiplication or something like that. You can do that as well. There's a function called dot. So, yes? It's not recording. I think that's a good question. I'm not recording it, but I don't know whether, I presume Benjamin and the chaps at CSPC are. I hope so. Yes, they are recording to the cloud. Okay. So let's see what this does. Those print statements where I'm just adding little labels, those are just for the human. They've got nothing obviously to do with the code. I'm just telling you what each one is doing. If you leave them out, it'll make no difference whatsoever. So what happened there? We got 225. Okay, some people are following along. I'm glad to see that. Why did we get 225 there? What is the dot product? Well, we say 1 times 1. Okay, my linear algebra is a bit rusty, so someone can correct. Yeah. Who was it who was extolling the virtues of linear? Was it you? Yeah. Some of our people yesterday were saying how much they absolutely loved linear algebra. I'm being ironic. Okay, so 1 times 1. Sorry. Where's the thing? 1 times 1 plus 2 times 4 plus 3 times 9 plus 4 times 16 plus 5 times 25. That should give you the value of the dot product. And the dot product is a scalar, if you remember your first year maths, right? Somebody else can check that if they really want to. If you want to do cross product, you use a thing called matmul, matrix multiplication. Right? I hope I don't do this wrong now. Okay. And anybody remember from the dim, horrible depths? And in my case, it was in the early Mesozoic era when the dinosaurs still walked the earth. When you did applied maths, can you remember what you should get out of a cross product of 2 vectors of 2? You should get a square matrix that are the same length, I think. Let's find out. No, you don't. Not in this case anyway. So when you're dealing with one-dimensional arrays in Numpy, it basically assumes that they can be flipped around or transposed as necessary. Okay? I'm going to go quickly back here because this is going to be a lot easier to just demonstrate on the fly. Bear with me. I want to try, so basically making rows into columns, it does nothing because it's one-dimensional. In Numpy, if it only has one dimension, that doesn't apply. But now what happens if I want to change the shape of the thing? Suppose I've got, let's do this in code again. Okay. So let's say that I've got some, I'm just going to use, somebody asked earlier if we had a whole bunch of numbers. Okay, that's great. There's 6 there, right? So I've got a list. Now, suppose I want to make that into a NumPy array. I can say, I'm going to call it data for want of a better name. np.numpy.array. Oh. No, it won't work there. Whoops. Print data. Okay. All right. See, it is actually an array. Okay, can you see there? Make that a bit bigger. Okay. Will anyone just interrupt me when these poor people are supposed to have a tea break? I think it's at 3, right? Okay. So you can make an array into a list, and you can make a list into an array. That's all fine. What happens if I want to change this into a 3x2 matrix? So there's a function called reshape. You can either do it this way, you can say a list.reshape, or you could say so you're telling it how many rows and columns you want it to have. Okay. What about the space? Inside a string, the space doesn't matter. Remember, this is a string. That's just text. It's just something that's going to display on the screen. This is the one. You with me? That's the variable. Okay. I'm just doing that so we can separate the two to make a bit more sense. Don't underestimate the value of doing that. When you get old and senile like me, your brain doesn't work so well anymore. You need to be able to keep track. Whoops, sorry. Let's try that again from the top. Told you I'm senile. There we go. So we started out with an array which was 6 by, well, just a one-dimensional 6. Now, all of a sudden, we have data 2 and data 3. And these things have got 2 rows and 3 columns. We told it we wanted 2 rows and 3 columns. And you give it a list which tells it how many rows and columns. If you've got a third dimension as well, you want sort of panes or layers, I don't know what the proper term is in your array. You want a 3-dimensional array, go for it, put a third value in there. If you want a 10-dimensional array because you're into string theory, be my guest. I don't want to know about it, but you can do it. Okay, you can have data, as far as I know, within the limits of what the computer can handle in terms of memory, you can have arrays as many dimensions as you like. Okay. So now, again, just to quickly, I'm quickly going to try something out here. In the, whoops, I go, so if I go data 2 plus data 3, basically just going to add them together again. 1 plus 1 is 2. 2 plus 2, oh, sorry, 2 plus 2 is 4. Right. So the same rule applies again. By the way, if you wanted to do that from the get-go with just like initialize it with lists like that without first reshaping it, you could have also done this. Two, four. You can have a list of lists. 6, 15, 22. Right? Oops, I'm missing a square bracket and another square bracket at the end. Okay. And then you could say data 2 equals np dot array 2. Okay. Let's run that. And if you go, oops, variable explorer. No, I want to go to variable explorer. Apparently you can't zoom in on the variable explorer. But if you look there, there's a list 2. Okay. You see it's now a 2-dimensional array. What's the shape of a 2-dimensional array? We type in data2.shape. 1, 2, 3. Now what happens if we transpose it? Now it's going to make a difference, isn't it? Well, it does. Just a capital T transpose it, and now you see the rows are become columns. So now instead of it being 2 rows and 3 columns, it's flipped it through around the two, flipped the 2 axes, so it's got 3 rows and 2 columns. And what used to be the rows are now the columns. Okay. So if we did something like this, we've got data 2 and data 3, they're the same size. Whoopsie. Come on. So if we try to say data 3 equals np.mat_mul, data 2, remembering that data and data 2 are both the same shape, they both got 2 rows and 3 columns. What's going to happen now? Oh dear, we got an error. Let's have a look at errors now for a moment. It says it's a value error. Input operand 1 has a mismatch in its core dimension 0 with GNU func signature. Yeah, okay, does that make sense to anyone? Let's take it slowly. What are we looking at here? Obviously something's gone wrong. So it says input operand 1 has a mismatch in its core dimension 0. Okay. When you are addressing elements in a list or an array or whatever, 0 is always the first one. So in the same way, you've got different dimensions, rows and columns. So they're telling us that there's a mismatch in the number of rows and columns. And if you think back to linear algebra, if you're multiplying 2 matrices together, the number of rows in one and the number of columns in the other one have to be equal. Otherwise it breaks. The universe sort of starts turning inside out, and the Cthulhu and the other old ones start manifesting, and all kinds of bad stuff happens. Don't do it. Okay. And you fail your maths test. Right. So if we want to do this, we want 2 by 3 and 2 by 3. What we'd have to do is we'd have to transpose that one. Okay. So then we've got multiplying a 2 by 3 matrix by a 3 by 2. Let's see what that does. Does it work? Oh, yeah. Now it's still telling us there's a core dimension problem. All right. Well, let's make life simple for ourselves. Let's take only the top row of the one and the first column, the first row of the one and the first column of the other one. How do we do that? Yeah. It's a bit like when you're defining x, y coordinates or rows and columns in the game of battleships, right? So in the first case, we want the first row, which is 0, and we want everything else. So in Python, there's a concept called a slice. And if you put a colon inside the list or something, you can tell it I want elements from this point to from this index to this index. So if you don't put the from and to, it just assumes it's the whole thing. And here we want the first column. So there we want all of the elements in the first. Am I doing this the right way around? I think I might be doing this the wrong way around. Let me think. This way we want the first. We'll check. If it gives us an error, then we'll know why. We sort of flip it around, then it should work. Okay. Too many indices for the one array. 2 indexed. Let me just see this. What happened now? Where's my Python console? Sorry, it's late in the day. Okay. I made a mistake. I see. I'm supposed to be using data 2 and data 3. Apologies. 2 and data 3. Okay. No. Just a moment. Sorry. Data 3 equals NB data array. Let's make that data 4, then this will make more sense. Okay. There we go. I was trying to multiply a 6 by nothing, or 6 by 1, a 6-dimensional one, and then I got myself horribly confused. So now I have I'm still confused. Just a moment. I already got dotted. Now I'm very confused. Why didn't that work? I shouldn't have to do that at all. Okay. Okay. So when you multiply, when you transpose the things and you multiply a row vector by a column vector, and you get a single number. I think that's right. If we did it the other way around, then we should get a 3 by 3 matrix. Not. Okay. Oh. Sorry, when I get it right, I will explain what I'm done. There we go. Okay. That's reduced it again. That's why we're getting that. All right. Let's try and multiply. Now that I found my other mistake, let's try and do the 2 full arrays. And there's a reason why I'm trying to do that. Okay, it worked. After I fixed up all my blunders, it worked. So I've taken the transposed data 2, and remember data 2 looks like this. So if you transpose that, then the one goes 1, 2, 5 down, and then 6, 15, it has got the 2 columns. 4. Now you'll see we actually get a 3 by 3. And if you go back and, which I evidently do need to do, go back and dig out your linear algebra textbook, you will see that if you multiply a 3 by 2 array by a 2 by 3 array, you will in fact get a 3 by 3 or 3 by 2 matrix by a 2 by 3 matrix. You should get a 3 by 3 matrix out. Basically, you multiply each element of the first row by each element of the first column and add them all together. And you do that with the second row and the second column and so on. Okay. So that was a very long-winded way of saying that you can multiply matrices together as you would in linear algebra. Okay. Apologies for all the blunders along the way. The point is, Numpy can do linear algebra a lot better than I can at this point. Okay. Somebody pointed out that I made a mistake. Thanks. All right. So a lot of you probably don't particularly care about linear algebra. And I did promise I was going nearly, I think we're supposed to have a tea break. So after the break, we will continue, and I will show you something which is probably of more general interest, which is curve fitting. Okay. Benjamin, is that the, do you think it's a good idea that a break now?
Yeah, we can take the break now.
Okay. Sure. So we're going to take a break now, and then we will continue, 15 minutes time, I think. That was embarrassing. All right. So after I managed to confuse myself slightly, let's just quickly recap what we did. We created two by 3 Numpy arrays in 2 different ways. The one was we reshaped a 1-dimensional 1 by 6 Numpy array. So they had 2 rows and 3 columns. The other one was we created a list of lists where each inner list represented one of the rows, came to exactly the same thing. And then I wanted to multiply the 2 together after transposing one of them which I then incorrectly said was equivalent to cross product. And one person, let's see who the culprit was. A couple of people actually noted that I made a mistake there. As I said, it was the dinosaurs were still walking the earth when I actually did apply first year applied maths. So yeah, my apologies, you're quite correct. Cross product is actually calculated differently, and it gives you a vector which is orthogonal to the two vectors which you, or something to that effect. At any rate, so to multiply the two together, you use the matmul, and that does a matrix multiplication. However, if you actually want the cross product, you say numpy.cross, and then you give it the two vectors that you want the cross product of. When I say vectors, what I basically mean is it's usually a one-dimensional numpy array. Numpy can probably handle multi-dimensional arrays for this as well. I just can't remember what the precise significance of that is if you delve into the maths. Okay, but let's just show you that it actually works. There we go. So if you transpose this one, if you transpose data 2, and you multiply the matrix multiplied by data 3, you get data 4. Okay? The cross product, you'll notice is very exciting. It's 0, 0, 0, because the first row of data 2, which I'm taking the cross product of with data 3, they're exactly the same. Okay? So if you're trying to compute a normal to the two and they fall exactly on each other, it's going to get pretty boring. So just to show you something slightly more exciting, let's take the second row and rerun that. So now you'll see you get a slightly different vector. All right? Open the variable so it's easy to visualize. No, that doesn't want to zoom. Oopsie, no. Okay, there is the variable in the variable explore. Why is it only showing? That's to search. Okay, there is the variable explorer. Is that what you meant by open it? Oh, right, let's do that. Okay. I generally don't use Spider. As I said, I use very old fashioned, so I use the command line and the text editor. There we go. That made it worse. Let's do that again. Okay. So that's data 4. Data 2. Where's cross data? Okay. So if you go and you draw out the vectors represented by the first row of data 2 and the second row of data 3, and you figure out what is a vector normal to both of them, then you go the plane that is defined by those two vectors, then you will get this vector here. All right. So quick, one or two last few things about linear algebra in Numpy. It can do a lot. Okay. Let's say I've got A equals MV. Suppose I want to solve a system of linear equations. Why is that? Go away. There we go. 2, 3, 4, 6. So I've got an A matrix, and I've got a B matrix, All right. So I want to solve that system of linear equations. Well, I first want to check whether or not it's possible. So if you want to do that, you want to check the determinant, right? All right. And if I remember correctly, if the determinant of a matrix is positive and non-zero, then you can solve it. Somebody who's got more, correct me if I'm wrong, oopsie. If D is greater than zero, it must tell us that. So I'm using an if statement, not an if loop, please. I hear, yeah, I die a little on the inside every time I hear somebody calling an if statement an if loop. It does not repeat. So most of the experienced programmers obviously know that. I'm probably preaching to the choir, but okay. This is something that you can do with print statements. If you put an F before the string, and then you put a variable name inside curly brackets, you have to put the F there. This is just a little aside. It's not part of Numpy, it's just a useful trick, a hack if you like. It will then actually print out the value there, and you don't have to muck around with converting things to strings and so on. See if I've done it correctly. Yeah. So it works out that the determinant is 54, so the matrix should be, or it's not really not solvable. What's the word again? It's not, yeah, it's not indeterminate. There we go, thanks. Okay, so I can now go equals np.lin. So linalg is a linear algebra sub library or sub module for the Numpy module or library. Okay, let's run that. Save and run. And let's go and look what's in sol. So if you've got three variables, we can call them x1, x2, and x3 or whatever. And you put them into a system of linear equations represented by these, or by this matrix, or these two matrices, the A and B matrix. X1 will have that value, X2 will have that value, and X3 will have that value. Okay. So you don't have a backslash operator like you do in MATLAB, but it's still pretty easy to solve matrix equations. All right, let's leave linear algebra away because I'm embarrassing myself, alone because I'm embarrassing myself. And let's actually have a look at something else. Do I have anything horrible? Let's see. Let's find the data. It must be there because I created it just now. So over here I have a CSV file. Okay. It's a much simpler CSV file than we were dealing with earlier. It's got two columns. Each column's got a header. Okay. If you're doing an experiment in a lab with, like an engineering lab, typically in my case, but you probably get similar sort of things. There might be some nonsense at the top, which you want to strip away, metadata and so on. And then you've got a whole bunch of columns, and each column represents a different the output of a different sensor, or if it's a simulation, it might represent a different property that you're trying to solve for, or whatever. But you've got some data. So we've seen that in pandas, you've got some fairly sophisticated tools for dealing with that and extracting it and filtering that. Numpy is not quite on the same level, but it still has some fairly good tools for dealing with this. Okay. Let's call it 2. Okay. So let's just make that a bit bigger so everybody can actually read it. Importing NumPy as you would expect. Now I want to actually get at the data inside that file. You saw there was one row that had headings in it, and otherwise it was just a whole bunch of floating point numbers. So let's do this. How are we going to do it? There's a function called load_txt in NumPy. Okay, and this is a lot like read from CSV in pandas, except it doesn't give you quite as many options. And instead of sending back a data frame, it sends back a NumPy array. So I'm just going to call my data because I'm very original. Thank you for that. First contact. Okay. Yes. Oh, sure. Sure thing. So following a very sensible request, I'm going to upload the where do I upload it now? Attach. No, I want, why is it, no, hang on. There we go. The data is now available on Slack. Okay. I will show you in a moment how to generate the data, because that's also somewhat instructive. So I'm assuming that the data is in the same directory as my program is. Let me double check. Maybe I didn't send it. Apologies, there we go. Okay. Thanks. All right. So that's how you do. You give it the file name. But now remembering that we can try and run it and you'll see what's going to happen now. It loads it, but it says could not convert string. We've got some text in the beginning. That's actually not what we want. So we've got to tell it skip rows equals 1. Also, while we're about it, it's in CSV format. CSV stands for comma separated value. So let's set the delimiter just to be safe. Let's zoom out a little bit so you can see the whole. Why does it show me that horrible? Oh, come on. There we go. Delimiter equals, is that still probably a bit small? Okay. So I've told it has to skip the first row. That means exactly what you would think it would mean. Delimiter is the thing separating the columns because it's just a text file with some text representation of numbers in it, although it's going to load them as numbers. It's smart enough to do that. Okay. Let's save that. We can actually let's just clear this and rerun it. So we're not cluttering it up with a lot of other stuff. Tells us it's an array of float 64, and you can see there's all my data. It's not very a lot of data, but it's enough to do the demonstration with. Okay. So there are 2 columns. Let's say that the one represents, well, what did I say that they represented? See, that's what it looks like. The one represents pressure, and the other one represents flow rate. Okay. So we did some experimenting which we were trying to relate the pressure in some other machine to the rate at which the fluid was flowing through the machine or whatever. Okay. So let's create a variable called pressure. Now we want to get only the first column. How do we do that? Remember, this is actually a NumPy array. all the rows in the first column. And similarly, we want flow rate equals data, all the rows and the second column. In Python, like in C, you start counting at 0, as you probably all know. Okay. Let's check that that works. When you're developing a piece of code, I can't tell you how important it is to do it step by step and test run it as you're going along. If you try and write the whole piece of code and test it at the very end, if it breaks, you're going to have a very large headache trying to solve all the problems. You will solve a problem and it'll actually get worse. And that's because there are 3 more problems you haven't yet found. So just like, yeah, if you don't know that already, test as you go along. You write a line of code, test it. Write another line of code, test it. Sounds horrible, but that's the way it goes. Okay, so somebody wanted to do a curve fit. We're going to do a polynomial curve fit. Most of the time, you're actually going to be doing polynomial curve fits. If you want to do something more advanced than a polynomial curve fit, there's a library called SciPy. If there's time, we can look at that a bit later. In very, very briefly, it's a huge rambling library with lots of scientific computing type of functions in it, but one of them is that you can do arbitrary curve fits in it. Okay? I will leave that as an exercise to you. For me, polynomials are good enough. I'm a mechanical engineer. I like hitting things with a spanner or a hammer, whichever's handy. Yes. Oh, you want? Okay. So what we're going to do is we're going to use a function called polyfit, which is in Numpy. So we're going to say fit equals np dot polyfit let's assume that pressure was varied and the function was the flow is a function of that. Okay. And that's going to generate a polynomial curve fit for us. We have to tell what order though, don't we? Let's do it with second order. Second order polynomial quadratic equation, right? We're back in high school. I can still remember that sort of. Now that's all very well. We've got to, let's have a look at what it looks like. So there's 3 little numbers. Okay? So those 3 little numbers are the coefficients of a polynomial, so a second order polynomial. So y equals ax squared plus bx plus c. Well, that's the a, b, and the c. Don't ask me which way around it goes. I can't remember offhand. If you go to the documentation. Okay. Oh. So if you don't know or can't remember, you go and look it up on the numpy.org website. And there it tells you, fit a polynomial, and it starts up with p naught, so that will be the c, plus x over time, oh no, that will be the a, sorry, so it's the x times the highest order, plus p1 times x times the order minus 1, plus until you just get to the constant, the c, which is on its own. So it goes the way you would expect it to. Mostly in Python, things are the way you expect them to be. Okay, so that's y equals ax squared, where that's a plus bx plus c. Right. We want to actually use that now. So let's say, let's create a new variable called flowfit. So fit equals, we want to evaluate the polynomial for each value of pressure. So we use a function called polyval, and we give it pressure. We're going to use the same pressure values, and no, sorry, we're going to give it the fit, the p, and then pressure. There we go. Ah, let's see how that works. There it is. Like everything else, it's got 11 elements in, so it's at least the right size. And they seem to be getting bigger as you go along, which you'd expect. Right. That's not actually very interesting to look at it here. Let's make a graph out of it. So you're going to use matplotlib. All right. All right. Again, let's use green circles. Right. And then for the curve fit, we want a line. So go plt dot plot. Again, we're using the pressure values, the same values, but now we're going to use the fitted flow rate. Fit. And let's use K for black, minus for lines. Again, if you know MATLAB, that convention of the symbols that you use should be very familiar. You can actually go and do some funky things and specify RGB colors. If you know what that is, you can have fun with it. If you don't know what that is, don't worry about it. And finally, and if you forget to do this, it makes you scratch your head a lot if you don't know what you're doing. I was that person a while back, a long time ago. All right. So the green dots are the experimental data, and you can see we've got a nice smooth curve going through them. What would happen if we had used a we try and put a straight line through to reduce it to first order polynomial? It's a line y equals mx plus k. I'll show you in the variable explorer. Now there are only two elements because it's m and k. Okay. And if you want a cubic, obviously then you make it 3. Okay. So it's actually pretty straightforward to do that. And a few other things. Suppose you want to get the average of the original data for each column, just while we're about it. You could say something like this. Data equals numpy dot mean data, and then you specify which axis. So if you want it to be rows, you want it to take the averages along each row, you give it a 0. If you want it to have axis along each column, it'll be a 1. If you wanted it to be into the page, if you've got a 3-dimensional data, then it'll be 2, and so on. Okay. I got the axes the wrong way around. It looks like it. Yes, it rather does. Did I do that the wrong way? Let's check. Yes. Sorry, I had that the wrong way. So 0 will average it by columns, 1 will be by rows, and so on. Okay. How do I know that? Because there are only 2 columns, so I should only have 2 values. So the average pressure is 5, and the average flow rate is 41.82. Okay. Oh, and of course, we might want to make the plot a little bit nicer. Dot. And so it's add labels and a legend. So this is just NumPy. This is matplotlib. This is not NumPy at the moment. Now I could do this for the units. Okay, but that kind of looks ugly, doesn't it? Let's see what it looks like. It looks So you can do some. There's one neat trick that you can do in matplotlib. if you know LaTeX, and yes, I'm showing my age, I'm a gray beard, I admit it, but if you put little dollar signs around the thing, it interprets this as a LaTeX. LaTeX is a markup language if you don't know about it. It's very useful for doing theses and academic papers and stuff with lots of maths in them and generally typesetting stuff. But it's smart enough that it actually, let's make it bigger so you can see, it actually shows it meters cubed per second. Okay, that's just another little aside. So I've used the mean here. You can also use the mode, and you can use, I think, probably the median as well. If you want to go and do other statistics on this, you can go and you can work out the standard deviation. So there's a whole bunch of different statistical functions. Okay? And then there are other things that you can do in NumPy as well. If you are into signal processing, NumPy and SciPy, for that matter, have both got their own fast Fourier transform library or sub-libraries. If you don't know what that is and you haven't been exposed to the horrors of signal processing, good for you. Although you actually, yeah, you lack, or you've been deprived of something potentially very useful. But yeah, anyway, I don't know if I've showed it in the past, and generally most people sort of start quietly snoring and drooling. So don't think we can show it now unless there's a massive amount of interest. Somebody's asking, you have 6 columns and you want an average in column 4. What code would you use? Somebody said you slice, which is quite correct. You can indeed slice. There's more than one way of doing it. There's always more than one way of doing it, in fact. So you've got data average now. If you wanted the second one, it's basically the same thing. You could say print data there, that will give you the second one, right? So by just using you could either slice it before you actually, slicing is when you basically tell it you want a range of things using the colon. See, if you only want the second one, you can just index, if you calculate it the way I did it here, you can just index it like that, and then you get only the second one. There's actually an option when you are doing load text, which I'll show you quickly here. You can also say use cols equals, and then you can tell it to only extract, people can't see my dramatic hand gestures, but you can only tell it, you can give it a list of indices. So you can tell it you only want column 0, which is the first column, and then the third column, which if we had one, and so on. There are lots and lots of optional parameters that you can add into this thing if you want to. It's a lot less capable than pandas. It's not as good as dealing with large and hairy data sets. But if you've got a largish table of numbers, you can still do quite a bit with it. It's a CSV file that you want to process in various different ways. You can still actually do quite a bit with that. You can decide at the time when you extract it or later to only extract certain columns. Why would you want to actually use columns when loading the data rather than just actually slicing it later? Somebody's asking about the chart title. Okay, that person in Wits, you forgot the equals after the delimiter. So, question for everyone. Why would I want to actually decide to only extract certain columns from the file rather than loading the whole data set and then, or under what circumstances might it be a good idea, rather than loading the whole data set and then just taking one of the columns by using a slice? That's a slice, by the way. Basically saying I only want one of the columns, or I only want one of the rows. Any of you guys got an idea? Let's see, yeah, there we go. Some people have actually got the idea. Speed and cost, system resources, large files, egg memory. Exactly. If you've got a data file which has got 3 million rows in it and 200 columns. It's going to take quite a bit of memory. If you've got a small old laptop because your department hasn't given you a lot of funding, you might not actually want to load all that data at once. You only want one of those 300 columns. So if you've got a very big data set or several big data sets, then you probably use calls to. It's not, either ways can work, but in certain cases, the one might have an advantage. In this case, you can save some memory. Very good. Excellent. What else did I want to do? Oh, suppose we want to show all of the data, all of the pressure data that is more than a value of 40. So there's one more cool thing that you can do. Or show which pressure data. Let's start off there. Actually, I'm going to do this pardon me again, I'm going to do this interactively because it's just nicer to demonstrate. Okay. Right. If I do this, is that too small? Pressure smaller than 40. Okay. It gives me an array. Okay, 40 is not a good choice. Let's do 4. That's more interesting. You can more clearly see what's going on there. So I've got this array 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's the pressure, right? So if it's 40, it goes true, 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 they're all true. And if I say pressure more than 4, it's true, 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 true. 0, 1, 2, 3, 4. Oh, sorry, true, 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 true. So it's 0, 1, 2, 3. 4 is not smaller than 4. 5 is not, so then it's false from there on. So it returns an array full of Boolean values, true or false, of the same size as the original array, but with true or false, depending on whether or not the condition that we specified is true. So effectively, it goes and evaluates that for each element in the array. Now, what happens if you actually want only the ones for which it's true? Well, then you can do this. So you use that array that's generated as almost like an index for, and you can't do this for lists, you can only do it for Numpy arrays. Use it like an index for, and then it goes 0, 1, 2, 3, because those are the only ones for which it's true, so it only returns the elements from the original array for which this thing over there is true. So that gives you some ability to filter numerical data based on whether or not. Now, there's a funny thing in Python. If I say it treats the true as a value of 1. And so the last thing we're going to do very, very quickly, because I think someone's going to touch on this in more detail later, but there's a cool way of calculating pi. Let's see if I can load it for you quickly. Where is it now? I saw it last night. Oh, pi. Okay. So there's a method of doing certain kinds of simulation or predictions or modeling called Monte Carlo simulation. And a simple way of explaining this is that if you take a large number of random numbers or a large number of random points on the two-dimensional plane, which are bounded between x equals 0 and x equals 1 and y equals 0 and y equals 1. So you've effectively got a square region, right? Clear that. In fact, I'm just going to close that. And you check which one of those are a distance of 1 or less from the origin, from x equals 0, y equals 0. So you're randomly generating points with the random x, y, coordinates, but x can never be, x and y have to be between 0 and 1. If there are any points which are less than, I'm going to just run it, and you'll be able to see. Okay, it's a bit distorted. Let's see if we can make it less. Okay, it's a bit distorted because the axes are not, they're both supposed to be the same length, but you can see that if it were not distorted, it would actually be a quarter circle. Because what's the formula for a circle? X squared plus y squared equals r squared. And in this case, the radius is 1. Okay. Now, if you take the area of a quarter circle, it's pi r squared over 4. And r is 1. So it's just pi over 4. What's the area of a square of unit of dimensions 1 by 1? Well, 1 times 1 is 1. So if you take the ratio of the area of the blue area to the ratio of the total area, the blue and the red area, you should get the pi over 4, it's the ratio of the blue area, over 1. Okay? And then you calculated pi over 4. And the more points you use, you then multiply by 4 and you get the value of pi. The more points you use, the more accurate it gets. Okay? So you could go and write a little for loop and you could say, generate a random x, generate a random y, generate another random x, generate another random y, and in this case, check, is it inside or outside the quarter circle? Or you could use Numpy, and Numpy's got another sum library called random. You can generate numbers. The uniform function generates numbers between 0 and 1. You tell it how many you want it to have in the array. Okay. And then you tell it you only want those numbers in the x coordinate for which x squared plus y squared is smaller than or equal to 1, and the same for the y. And that is a very nice and convenient way of doing that. And if you then go and you say, you add up remember, all the true values are going to be equal to 1, and all the false values are going to be equal to 0. And then you go and divide it by the total number of points we generated, and it should come out to multiply by 4. And there you get 3.142666, which is a pretty good approximation of pi, actually. If you jack it up a bit, let's make that bigger. No, that bigger. Oh, where's my Python console? So in theory, if you use enough points, it's a terrible way of calculating pi, but it's a very interesting way. But you can use that property that you can actually reference only those things which are, and get a value of true or 1, where a certain condition is met. And you can use that in fairly creative ways if you like. If you were to write this program in C or something else using a for loop, it would take a lot more lines of code than this. The part that's actually doing the hard work is 4 lines. Okay, so that's the power of Numpy. If you have to do, as I said, moderately complex things with mathematics, using data in more or less tabular format or in array format, this is probably a very good tool to use. Okay, any questions? Let's see, there looks like there's a question over there. Okay, Shepard Wits. Yes, Numpy is Pandas gives you a way of manipulating large data sets, but I don't believe it can do linear algebra. I stand under correction, but numerical methods and so on are very much more a NumPy thing than a. So what you can do is if you've got a large complicated Excel file or something, you could use pandas to read it in, and then in pandas there's a function called toNumPy. Can we save the plots? Yes, you absolutely can. Let me show you. You can do this. pl.savefig. There we go. So in matplotlib.pyplot, there is a function called savefig, and you just tell it what you want, and it's smart enough that if you give it a .jpg extension, it knows you want a JPEG. Let's see if it works. Let's go and look at where are my JPEGs? Trying to see it. Don't see it offhand. Let's refresh. There we go. You can save it in JPEG or PNG format or EPS format or most other common formats. Okay. Someone earlier was asking about adding in a title. Not sure if that will work. Let's try it out. In this case, it didn't put a Greek letter there. Disappointing. Oh well, that's how you put a title. You just say pl or plt.title. Okay, other questions? Who's x squared plus y squared? Okay, so remember x is a NumPy array of random numbers. And those x and y are representing sets of x and y coordinates. Okay. So what we're checking is which one of those are going to return true. So if you take this thing, let me show you what it's going to. Well, let's make this much smaller. Let's make that 10. Okay. Now it says pi is only 2.8. So if you use too few points, it's very definitely inaccurate. Now if we say x times 2 plus, or x times x plus y times y, that's equivalent. Okay, it gives you some numbers. If you say which one of those are greater than or smaller than or equal to 1, it tells you for which points it's smaller than or equal to 1. In other words, which ones are inside that quarter circle, right? If you then sum it, all the falses are equal to 0 in Python, and all the trues are equal to 1. So you're effectively counting the number of points which were inside that circle. It's a clever, non-intuitive, well, I flatter myself to say it's a clever, but it's a non-intuitive but quick way of calculating how many points are inside the quarter circle. Does that make sense? Uchenna is asking about the $sign. I was trying to be clever there, but it didn't work here. Sometimes you can get it to type out Greek letters or show things to the power of 3, like I did just now. Where's that code? Oh, that's the wrong, just a moment. So like I did there, you don't have to put the dollars there. I was trying to get it to show a Greek letter. Evidently, it's not quite that smart. But the idea is just that it can actually show, it can sometimes show slightly better mathematical notation in your axes or in your labels if you do that. And if it can't, it'll just type something out for you. Does that help? No, it doesn't help. Oh, it's because I'm forgetting my LaTeX. If you use LaTeX terminology, there we go. If you use LaTeX terminology or LaTeX syntax, it'll actually you have to put a backslash before it. There we go. It actually puts the letter pi there for you. Otherwise, you can just do this. And it'll just write up. Come on. And it just writes it out for you. You don't need dollars then. But it looks nicer. Okay. Yes, somebody else beat me to it. Yes. Okay. Jan, yes, you're quite correct. You could generate an interval -1 and 1, but then you also need to generate still more points to actually get the accuracy. So it'd be conceptually simpler, but your computation will require more points to get I think. Okay. That's all I wanted to show you, really. There's lots of other things I could show you, but that gives you an introduction and some sort of idea of what you can do using Numpy. Very, very useful little library. I use it quite a lot. Rahul, you're asking if it only outputs the true values? No. The values which are true will output as red, the other values will output as blue. So you'll see over there, check for values which are smaller than or equal to 1, and I output those as blue circles, and the ones which were greater than or equal to, or greater than 1, I output as red, sorry. So it shows both of them. By changing the condition, I could choose which set I wanted it to actually show in the graph. Those are the sort of things you figure out fairly quickly if you play around with it. Okay, anyone else? My own group seem to have all died of boredom, so I think I must let everyone go. Okay, thanks everyone.
Well, thank you so much, Andrew. It was a great presentation, and hopefully everybody had a good intro to Numpy or Numpy if you didn't know about it. So thank you so much, and we'll continue tomorrow. Thank you.